Picking it up right here, number 11. This is review number 3. This is the second part of review number 3. And so our question is 5 over 3x minus 2 equals 2 over x plus 3. So, all right, so how do we solve two equations equal fractions like that? I don't remember if we've done any of these. The easy thing is to cross multiply. So when you have two equal fractions, just go diagonal, diagonal. I found that's the easiest thing for people over the years. So let's do that. So diagonal, diagonal. So 5 times x plus 3 is 2 times 3x minus 2. Is that good so far? So I just did diagonal. So, upper left, lower right, and I just laid them flat. Just diagonal, diagonal, but then lay them all out flat. And now you know what to do with the parentheses, right? We just distribute. So 5x plus 15 and 6x minus 4. Good so far? So now here's the wall. Remember, we're solving this whole section 1.3. I'll just put it right here. It's all about equations, huh? Every problem in review 3 is going to have an equal sign. It's all about equal sign problems, equations. So it means we have a left side and a right side. All of our thinking is left-right. And x is yelling out, I want to be alone. So we got to get x alone. So do you know we first should do something with the 5x and the 6x. In other words, don't worry about the 15 and the negative 4 yet. We'll get to those in a minute. But really our first order of business is to do something about those x's. And specifically, we want to get rid of one of them, huh? Because we want to get the x in just one spot. I usually say get rid of the lower one. Either one is fine. It'll work either way. Basically, just get rid of one of them, and you're good. So the lower one is 5x, so I'll do that. So what am I going to do then exactly to get rid of that 5x?
Subtraction both sides.
Yeah, exactly. Subtract 5x. Subtract 5x from both sides. Now notice that's an action that I'm taking on the equation, huh? So the equation was there. I'm subtracting 5x from both sides. So I'll draw my line and then come down and show the results of that action. You want your work to look just like that. That's how, not just Heron styles, but every math person, they come down. They don't go off to the side or do things like that. That just gets disorganized. Come right on down in your work like that. These will cancel. And then we have 15. 6x minus 5x is just 1x or plain x. Either way, it's good. And then x is still yelling out, I want to be alone over here on my side of the wall. So now what do we do to get x alone? Add that 4, huh? Yeah, we'd always just do the opposite of whatever's with x, huh?
You always do the smaller number.
Well, no, that's only for x's. Good question, Angie. Thank you for clarifying. Yeah, that's only when there's x's. When it's numbers, you just do whatever's next to x. Everybody hear Angie's question? Probably other people are wondering the same thing. It's a good question. So when I said do the smaller, that was only for x when you have two x numbers on both sides. That's not the case with the 15 and the 4. I'm not doing the 4 because he's the smaller. He happens to be the smaller. But that's not the reason why. It's because he's the one with x. Right? So that's a different story. When you have two x's, do the smaller. But when you're just down to dealing with the numbers, you got to get rid of whatever's with x, whether he's bigger or smaller. So I got to get rid of that minus 4 by adding 4 to both sides. Good question. That's helpful to everybody. Please ask that stuff. And there we go. 1x is 19. Or just x. You don't need the 1 in the front. It's not doing anything, right? 1 times x is just x. There's our answer. Other questions on that one? Is that good? All right, I'm going to move on to number 12. If I'm going too fast in any way, I sort of have to go this pace. But remember, everything's on YouTube. You can slow it down and watch it at your leisure. So 2 over x minus 2 minus 6 over x plus 1 plus 22 over x minus 2, x plus 1. Okay. All right. So this one is kind of difficult. So that's why I wrote on the board for you about fractions. And so let me just stick it on the YouTube also, just so everybody has it. So when it comes to fractions, what's the story? Well, there's two kinds of things, right? If there's no equal sign, that's not the case, but that will be the case. Or do we already have some of those? I'm losing track. But somewhere we'll have ones without equal signs. That's not this section. If there's no equal sign, then you just multiply top and bottom by, to make, top and bottom, I should say. How about I add something here? By whatever's missing, by whatever's missing to make the LCD. But that's not our case. We're over here if there is an equal sign. We do have an equal sign. So we're not going to do top and bottom. We're not even thinking top and bottom, huh? We're thinking left and right whenever we have an equal sign. So we're going to multiply left and right. Left and right by the LCD, and I'll over 1 to cancel. I have a few more words here. To cancel all denominators. And then I put a note on what the LCD is here. So for either case, what is an LCD? An LCD is the lowest number that all numbers divide evenly into. And then for letters, and one of each letter type highest power seen, I'll add. Highest power seen. So let's go do exactly that. So this one has an equal sign. So on the exams we take, you'll have some with equal, some without. You've got to know those two kinds. So when you have an equal sign, all of our thinking is left, right, huh? We're not going to do top and bottom. What I mean is, here's a mistake a lot of people make. They'll come in here, and they're thinking sort of right, but it's the other kind. They'll come in and they'll go, oh, I know, this is x minus 2, this has got x minus 2 and x plus 1. So they'll multiply top and bottom by x plus 1 like that. That's not right. That's not what we want to do. We shouldn't be doing top and bottom. We shouldn't even be thinking top and bottom because we have an equal sign. All of our thinking should be left, right. Easy mistake to make. In fact, if that was just simply a plus or a minus, whatever, same thing, in the middle, that would be exactly the right thing to do now. That would be exact. You'd want to multiply top and bottom of that one by x plus 1, right? And then you'd need to go to the middle one, and you'd need to multiply top and bottom, by minus 2, by x minus 2, right? Because those are the parts that are missing. That'd be the first kind I was telling you about. That'd be, if there was no equal sign, then you would multiply top and bottom by what's missing to make all the bottoms the same. But that, right? And it's the visual change is not much, huh? All I needed to do was change that little equals to a minus or a plus, whatever, same thing. And suddenly the technique would change, wouldn't it? So this is something you really have to know. It won't jump off the page and grab you by the collar and say, hey, look, I'm not an equal sign problem, or I am. It's pretty small. So you have to be looking for it. So, okay, so back to it. We have equals. So that's a small symbol with a big meaning. So that means we're not going to do top and bottom. None of our thinking is top and bottom. All of our thinking is right and left, huh? Left and right. All of our thinking. So, okay, so what do? We multiply the left and the right by the LCD over 1. So what is the LCD? It's one. We don't have any numbers. It's one of each type. So it's x minus 2 and x plus 1. That making sense? So that is the LCD. And what am I going to do with it? I'm going to put x minus 2, x plus 1. It's over 1, but I'm not going to bother to show the 1. I'm just going to put it in the top. And same thing right here. X minus 2, x plus 1. Same thing right here. X minus 2, x plus 1. That is the correct first step now. Does everybody see that? I just multiplied through it. It's over 1, over 1, over 1. In all three cases, I don't have a lot of room to squeeze that in. But you multiply through by the LCD over 1. Why? First off, why is that legal? Why is that okay to do? Don't I have to do the same thing to the top and the bottom? The answer is no, not when you have an equal sign. Remember, when you have an equal sign, that means the left and the right are equal, which means you can do anything you want as long as you do it to both sides, right? If they were equal before and you treat them the same, they're going to be equal afterwards. I could multiply both sides by 1,000,000 if I wanted to. If they were equal before, they'll be equal afterwards, just 1,000,000 times bigger now, but still equal, huh? So I don't have to do the bottom. I just have to make sure that whatever I do it to the left and the right, all the terms on the left, all the terms on the right. That's all my thinking, left, right. I'm not thinking top, bottom. Now, if we didn't have an equal sign, then you got to do top and bottom. So you get the idea in math, we're always keeping the balance. 2 ways to do that, left, right, or top, bottom. How do you know which one? If you have an equal sign, left, right. All of your thinking is left, right. Okay, better get back to it. So what do we do now? So if there is an equal sign, you multiply left and right by LCD 1 to cancel all denominators, right? To cancel all denominators. So let's do that. X minus 2, gone. Well, what's left in that first fraction? What's left over? This 2 here and the x plus 1. If you can read all my scribbles, is that clear enough for you to see? Is that okay? Can you guys over here see that okay with that glare and everything? And then in the middle one, so remember, we're going to cancel every denominator. That's what the LCD's job in life is. I used to call it a hitman in past semesters to help people think it's going to take out denominators. So it's going to take out the next denominator. What's left over? That in the middle. That minus 6 and the, what is that, x minus 2 plus, and this plus sign comes on down. And then what happens on the third fraction? Again, takes out denominators. Look at all denominators have been canceled, taken out. LCD is a hitman, so to speak. It just takes out denominators. What's left on that third fraction? Just the 22. Isn't that much nicer now? No more fractions. That's what we do on the first step. You can take it from here, right? Can you whip it out? Good. I'm hoping you're good. Feel free to speak up if it's not seeming good. So minus 6x plus 12 plus 22. Okay, now here we are in this situation again where we have x's on both sides, like Angie was talking about. So we have x's on both sides, right? And we do that first. Now, I'm not going to worry about those other numbers. My first order of business is those x's, the 2x and the minus 6x. First, deal with them. Specifically, get rid of one of them. It really doesn't matter which one. You can get rid of either one. You just don't want it in two places, right? You want x eventually to be in only one place. So I usually do the lower one. Which one's lower, technically? The minus 6x, because that's negative. But it doesn't matter. You can do the other one. So I'm going to get rid of this guy. But there's my focus, right? I'm looking at those two x's, and I'm thinking I need to get rid of one of them. It doesn't really matter. Like, you could go minus 2x in both sides. That'd be okay. That would cancel out the 2x, and that would work fine. I'm going to actually get rid of the 6x, but it doesn't really matter. I'll go plus 6x to both sides. Either way will work great. Just do the opposite of one of them, but you got to do it to both sides, right? Got to keep the balance. And then this will cancel out. And 6x and 2x. And notice I draw my horizontal line because I took action. And I'm going to draw my line and show the results of that action. So this is going to be 8x plus 2. Drops on down. These are gone. Now 12 and 22. I'm just going to add, what is that, 34? And x is still yelling out, I want to be alone over here. Get rid of that 2 and that 8. What do we do next? Subtract the 2, right? We good? Subtract the 2, draw your line, show the results. So down comes an 8x. Over there is a 32. Last step to get x alone is usually divide. It's not always, but often. And 32 divided by 8, 4, and there's our answer. We got x alone. Questions I can answer on that one? First step is by far the hardest and the most important. Multiplying through by LCD over 1. LCD over 1, LCD over 1. When you have an equal sign, left and right by LCD over 1. All right, on we go. If you're good, number 13. 13 is going to change gears. It won't be hard. 3x, this will be a lot easier. 3x, absolute value, 3x plus 9. Remember those straight lines are absolute value? Remember that from earlier math classes? What do they do? Like, what are the straight lines on negative 2? What does that equal?
2.
Yeah, just regular 2 or positive 2 if you want. It makes things positive, huh? Those straight bars called absolute value bars, they just make the thing between them positive and then they disappear. Right? Pretty simple. Not hard. Okay. But it does get a little more tricky when an x gets involved, like on this problem. So let me ask you, what if I had absolute value of x equals 3? Okay. Now again, absolute value makes anything inside positive and then vanishes. So what are the solutions to this? Let's just think it out logically. If somebody gave me that equation and they asked me, hey, what can be put in there and will make it work? What works? Yeah, does everybody see you could plug in negative 3 or positive 3, and either way it'd work. It'd make it true, wouldn't it? Because the absolute values would make it positive, right? You could put a negative 3 in there, or you could put a plus 3 in there. Either one, and the absolute value would come out regular 3, wouldn't it? So we actually have two answers. Plus 3 or minus 3 to that simple little equation. You agree? Seem reasonable? Well, that's the basic idea behind every absolute value. Even when they make bigger, like the one we got up there, it's that fundamental idea. And that is, the thing inside the absolute values can be the positive or the negative of the right side, 7 in this case, positive 7 or negative 7. And either way it'll work because the absolute value will make it positive in the end. So it really gives you two options, doesn't it? That's what absolute value does. So let me write that up. So solving absolute value equals. How do you do it? So if you have absolute value, and I'll just say inside. Let's give a general rule here. If you have the absolute value and you have whatever inside equals a number, what you do is you say, hey, that inside could be the negative number or the inside could be the positive number, and then you solve. And notice, from here to here and same thing to there, I remove the absolute values, didn't I? I removed them. Does everybody see that? That's the removal step. So that's how we handle solving absolute value of anything. Does that seem reasonable? The more it makes sense, you'll remember it long term. If it's just steps on a board, who knows why they're true, that won't stick with you as well. Does that make sense? If if somebody gave me again absolute value, whatever, blah blah blah, equals 7, well, that means that inside blah, blah, blah could be 7 or negative 7. And either way, the absolute value of it will come out regular 7 and the equation to be true. Right? That makes sense? We good on that? So it just means that the inside has to be 7 or negative 7. And then the equation will be made true because the absolute values will turn it back to positive 7, whatever it was to begin with. So that's the idea. That's the steps we're going to take every time we get an absolute value equals problem. So getting back to this one, what do? I take that inside, and I say, okay, inside you can be 7, or inside you can be negative 7. It becomes two equations, doesn't it? And notice, no more absolute values. I yanked them off. Right? I took the inside out. The snail came out of his shell. Right? I pulled the inside out. It's kind of a gross analogy, but you know what I mean. Right? And that's reasonable, isn't it? That inside 3x plus 9. If that inside is 7 or negative 7, either way, the absolute value of it will equal 7. and the equation will be made true, won't it? So then I just solve those two different versions. So I got two equations. So here's one, and there'll be another one over here. So let's take action. So X is yelling out what he's always yelling out. I want to be alone over here. So what do we do to get X alone? Minus 9 from both sides. Cancels out there. 3x is minus 2. Last step is usually divide by whatever's next to x, right? Because it's multiplied. So there's one answer. X can be minus 2/3. Now the other answer is going to come from the other side. So on the other side, we've got to solve this one also. Subtract 9 from both sides. And we get 3x equal. And the other side, minus 7 minus 9. Just think about money. If you lose, positive is gain, negative is loss. We all deal with money. So if you lose $7 and lose $9, how's your bank account? It's way down, huh? Yeah, they actually add. You all sense it. Yeah. Down $16. Last step to get X alone is just to divide by that 3 again. There's the other answer. So we have two answers, and you just put them into Math Excel with a comma. Like that, minus 2/3, minus 16/3. Either order, you can put whichever first and second. Those are the two values that make the original absolute value equation true. I just realized I got to add one more step to this instructions here. Step 1, get rid of anything that is outside the absolute value. Well, that's not, I'm not saying that very well. How about this? Get the absolute value alone on his side. And then step 2, do that inside thing. So step 1, get the absolute value alone on his. Okay, let's go back to it. So, or let's go to 14. So 14 is absolute value 1 minus 5x. It has a t, but I'm just going to use x because my t's look like plus signs. It's confusing. All right, there's the equation. Do you see why I just wrote that extra step 1 in there? Because the absolute value is not alone. Here's the equal sign. The absolute value is not alone, is he? Here's the absolute value, and here's 3 hanging out with him on his side of the wall. We got to get rid of that 3. Before we do anything about the positive, negative, and all that monkey business, which we will do in a minute, we first have to get rid of that 3. You have to get the absolute value alone first. And then you go on to the other positive, negative stuff. Does that make sense? We didn't have that back on 13. See the difference? See the absolute value was already alone on 13, the one we just did? There was nothing on that side with him. He was already alone, so we didn't have to worry about that. But on 14, first, so what's my first step? What's going to get rid of that 3? Yeah, subtract 3 from both sides, exactly. So there's step 1. So step 1, get absolute value alone. So then we have absolute value 1 minus 5x equals, what's that, 16? Okay. So first step, get the absolute value alone. Second step, remove. Remove the absolute values equal to the positive number. So inside equal to positive number. Inside equal to the negative, right? So you remove and you write the two equations, the positive and the negative. So I'll just take this inside out and I'll say, okay, inside you can be positive 16 or, and why don't we do the negative one first? It's something we're going to do probably not till next week, but it'd be a good habit to get in. We'll just do the negative first. It doesn't technically matter, but it might make life easier for us. Or 1 minus 5x is positive 16. So step 1, get the absolute value alone. Step 2, remove the absolute values. And the inside is the negative number and the positive number. And then just solve both those equations. So right over here, x is saying I want to be alone. And right over here, it's saying the same thing. I want to be alone. Get rid of all this stuff. Get rid of the 1. Get rid of the negative 5 that are on the x so that he can be alone. Give you a second. Can you whip those out? So first I subtract 1 from both sides. And then what does that leave me? Negative 5x. And what's that? Negative 17. Last step to get x alone on this one, divide by minus 5. Notice whenever we divide by the exact thing that's next to x. Same sign, same everything, huh? If there's a negative 5 next to x, I divide by negative 5. Why? Well, because I want everything to cancel out. I want the 5s to go away and the 2 negatives to make positive, so there's nothing left next to x at all. All right, so now let's do the other one. I'm going to go minus 1, minus 1. That cancels. Got minus 5x is, what's that, 15? And then I'm going to divide by minus 5. And that leaves x is, what's that, negative 3? Oh, yeah, what happens with this 2 negatives here? 2 negatives makes? Positive, so that's 17 fifths. So then the 2 answers are 17 fifths, positive, you know, comma, negative 3. There's our 2 answers. Math Excel wants you to enter them with a comma, either order. You put the negative 3 first, doesn't matter. There we go. Questions on that one that I can answer? All right. So let's move on then to number 15. And I'm going to make it x as x squared plus 2x minus 35 equals 0. So I'm writing out the x squared strategy. I have it on the board there for you. How do you solve things that have x squared? So that's a lot of what we're going to do today. We're going to crank out a lot of these. So first off, I wrote the instructions there. I'm saying when you're solving an x squared with an equal sign, if you have x squared and regular x, do we? Is that us? Oops. Yeah, we have x squared and we have a regular x, don't we? We have both x squared and a plain x. So what do we do then? First step, get a 0. Then try to factor. So already got a 0. Step 1, get a 0. It's already done. That's nice. Step 2. What should we do on step 2? Try to factor. So we reviewed factoring just recently. So let's try to factor. How do we factor when there's 3 terms? Or I should say, what's the first question we always ask ourselves when we're about to factor? First question is there a GCF? Is there something they all 3 have in common? Is there something... Do they like all have an x? Nope. No, the 35 doesn't have an x. Is there like a number that goes into all of them? No, there's no number at all in the front of the x squared. So so there's nothing in common. It's good we looked for it. There's nothing in common. So that didn't work. So what do we do now for 3 terms? We always do the 2 parentheses. After we try to do GCF, and there was no GCF. So we go to the 2 parentheses. Remember how this works? What goes in the front of each parenthesis? Yeah, just a plain old x. Right? And then remember how we figure out the numbers that go in the back? Yeah, what multiplies to be 35, what multiplies to be the number at the back, and what adds to be the number in the middle. Because that's what happens when you multiply 2 things with 2 things. The numbers at the back multiply, and the middle comes from adding.
5 and 7.
Yeah, it's going to be 5 and 7. Either order, doesn't matter which one you put first or second, but the signs will matter. Order doesn't matter, but signs do matter, huh? And how do you do the signs?
One in the middle.
Yeah.
To the biggest number.
The sign on the middle goes to the bigger, doesn't it? So whatever sign you have in the middle, he goes to the bigger. 7 is the bigger than 5, right? And plus 7 minus 5 will make plus 2 in the middle, and they will multiply to be negative 35. 5 times 7. Good there? Does that make sense? All right. So now, try to factor. We did factor. And go back to the instructions. Try to factor and then set each one equal to 0. So each equal to 0 and solve. So you set each one. So you grab the first one. Again, we're going to have two equations coming at us. The first one is 0, or the second one is 0. Why are we allowed to do that? Why can we set each of them equal to 0 like that? Seems kind of weird, isn't it? Why did we go from 1 equals 0 to 2 equals 0 like that? Did we talk about it last time? I honestly can't remember. Did I say I'm thinking of two numbers in my head, and I times them and it comes out 0? What does that mean? Did we do that at all?
Yeah.
Yeah? Some say we did. Some aren't sure. I'm not sure either. All right, well, let me say it again. Can't hurt. So if I was thinking of two numbers in my head, okay, I'm thinking of two numbers in my head, and I times them and it comes out 0. If I'm multiplying two numbers and it's coming out 0, what does that mean about my numbers?
Product is 0.
Yeah, either one could be 0 to make them times and be 0, right? If the first one is 0, 0 times anything would be 0, wouldn't it? If the second one is 0, anything times 0 would be 0, right? So if two things are timesing to be 0, that means either the first one's 0 or the second one's 0. And that's what this is saying to you. Something times something is equaling 0, right? Those parentheses mean multiply, right? If two things are timesing and the answer's coming out 0, that means either the first one is 0 or the second one is 0. That's just reasonable, isn't it? All right, and now we just solve both those two little equations. Let's do it. So x is saying I won't be alone. So we add 5 to both sides. So x is 5, and 7 is saying I won't be alone. I'm sorry, x is saying, to get rid of the 7, negative 7. So what are our answers? 5 and negative 7. Either order, just put a comma between them, and Math Excel will be happy. And we live to make Math Excel happy. There we go. Questions on that one? Okay, let's try that one. So use those instructions that are on the board or on the video thing that show you how do you handle an x squared with an equal sign problem. That's a 5 there. Make that a little better. All right, so again, the first step is get a 0 when you have x squared and x. So get a 0. I say, okay, here's the wall. So I'm going to subtract 30x from both sides. This cancels and just leaves 0 because there's nothing left on the right side, huh? So that's 0. There's our 0. Now what happens on the left side? Can I subtract those numbers like 25 minus 30? No, those are unlike. So they just all go there together next to each other, but nobody combines, huh? 25x squared minus 30x plus 9. So far, so good? Now, what are we going to do from here? Well, so step 1 is get a 0. We did. Step 2 is factor, huh? Okay, so that means like with the parentheses. First off, we should ask, is there something in common to all three terms? Is there a number that goes into 25, 30, and 9? Now, I was thinking about 3, but 3 doesn't go into 25, huh? And they don't all have an x, so there's no GCF, so we skip the one big parenthesis GCF step, go right to the 2 parentheses. So we'll go right to the 2 parentheses. Now, this is the harder kind because we have a number in the front. 25x squared, but it's not impossible. We can do it. So remember, you're going to have something in the front, something in the back, something in the front, something in the back for each parenthesis, and they have to multiply, two things with two things to go back and be the 25x squared minus 30x plus 9. So what about these two spots? What about the front and the front? How can they make 25x squared? What times what? It's multiply, right? It's all about multiply. The front and the back come from multiply. The middle, remember the middle comes from adding, right? But the front and the back come from multiplying. So how can the front, what times what multiplies to be 25x squared? Yeah, 5x. 5x. Okay, now how about the back? What multiplies to be 9? 3 and 3. Now, the sign in the middle tells us the signs, doesn't it? It's got to be negative. Now, you might be thinking, yeah, but Mr. Heron, 3 and 3 doesn't make 30. Right. This is a harder one because of the numbers in the front. Are you clear on that? In other words, it's not so simple. It's not like, let me show you what I mean. Let me compare. Let's go back. See 15 here? See how he had no number in the front of that x squared? Those are the simple ones where the 5 and the 7 add and subtract to be the middle. They simply do that when there's no number in the front. But when there's a number in the front, like 25x squared, it's not so simple. This is the right answer. It is correct. But it might not seem correct to you at first. You might look and go, but 3 and 3 don't make 30. They're not even close to 30. Well, here, I'll prove it. It's right. You don't really need to do anything else, but let me show you. Let me do a check over here real quick. I'll just show you that it really is right. 5x minus 3, 5x minus 3 really is 25x squared minus 30x plus 9. It's true. Let's see it. Boom, boom. Remember how to multiply two things with two things? They just take turns, right? The first goes to both, and then the second goes to both. So 5x times 5x, 25x squared. 5x times minus 3 is minus 15x. He's done. Now the minus 3 will go to both. Boom, boom. Minus 15x, and then minus 3 plus 9. See how those two in the middle make minus 30x? See how it goes back perfectly? So it's a little more complex, isn't it, when there's a number in the front? The 3 and the 3 actually become 15 and 15 when they multiply the 5s, and that's why it's 30 in the middle and it's right. This takes time to master. This will not come to the casual. If you're casual, if you're working 40 hours a week and taking 18 units and only have 2 hours a week to give this class, you might as well do something else with your life. You're just going to have a bad experience. This is just one example. As I remember my own daughters, when they were back in a couple years ago, taking this basically, pre-calc a couple years ago, and doing this with them, and then both of them saying, Dad, I hate factoring. And I said, girls, if you want to go on in math, you got to learn to factor. And one of them did and one of them didn't. You know, it's fine. One of them went and did something else, and that's fine. But if you want to go the road of STEM, the other one's majoring in chemistry now. You need to learn this stuff. So, and it takes time. That's why they said, I hate this, Dad, because they knew they weren't getting in and they had to put in more hours. So you got to practice. Questions I'm glad to answer, but you really got to just spend time going over these problems, to get used to recognizing number in the front's harder. They multiply. You got to do this checking yourself. You got to foil things out so many times to where you can start seeing it happen. All right, enough with the speeches. Let's go. So we're still not done with this problem. So we factored. What do we do now after factoring? Set each equal to 0 and solve. Remember, that's the whole point, right? If two things are timesing to be 0, either one could be 0, right? So once we factor, then we say, okay, the first one could be 0 or the second one could be 0. So then we just solve, just like the last one, right? After you factor, two things timesing to be 0 means either one could be 0 to make that happen, right? But, of course, what's going on here? They're the same. So there's no use in solving the same thing twice. There's only going to be one answer. Just solve one of them once, and you're done. It's nice. So what do we got? X is saying, I want to be alone, like he's always saying. What do we do? Add the 3. Exactly. Boom. So 5x is 3. Next step. Divide by last step is usually divide. There it is. So there's only one answer to this problem. 3/5. There it is. Questions I can answer on that?
What's the easiest way to get that 3?
Let me clarify. Let me say that for everybody real good. Yeah, right in the beginning, I look at the 25, and I say, what times what's 25? 5 and 5. Those go in the front to make the front. And then I jump to the back. I say, what times what is 9? 3 times 3 in the back to make the 9. That's what makes me think of that.
All right.
Good question. Other questions on that one? All right, so number 17. 40x minus 39 equals 40 over x. All right. So a lot of learning to do math, especially pre-calculus, is what this basically is. College algebra, pre-calc, pretty much the same thing. Not if it, pre-calc is this plus trig, so it's virtually the same thing. So what is to categorize things, classify things, have a game plan. So lots of educational studies have shown that people that do well in math and science and foreign languages, their thinking is organized in different shelves in their mind. So I'm trying to help. So I'll be trying to help you do that anytime I can. As you look at this, before we dive into any particular thing, what category does something on the board addresses it? It fits one of those categories right now. It'll actually morph and become another category secondarily. But right now as it stands, which one of these is it? Well, first time, is it x squared? Is there x squared? No. There's no x squared anywhere. There will be in a minute. But there's not right now. There's no x squared. It's not an x squared. Well, what is it then? Is it absolute value? Are there absolute values? No. There's no absolute values. What else do we do? Is it a fraction? Yeah, there's a fraction on the right side. So that's what you should dial in with. So that's how you want to attack this. You want to learn the different kinds. And you want to look at that and go, oh, that's a fraction one, and then go to your steps. Right? That's why I'm laying out those steps for you. So when you see a fraction one, you go, okay, it's a fraction. On the right side, there's a fraction. So what am I going to do? If there's no equals, oh, no, I do have an equals, right? So right here, there is an equals. What do you do when you have a fraction and there's an equals? You multiply the left and the right by the LCD over 1 to cancel all denominators. So that's what we're going to do. That makes sense? There's a game plan for every type. So let's go do that. So I'm going to, it's a fraction on the right side. So I'm going to multiply by the LCD over 1 every term, multiply all terms by LCD over 1 and cancel all denoms. How many denominators do we have right now? Only one. So it sounds dramatic. All denominators, just one. But anyway, so what is the LCD? So again, I put that up for you. The LCD is the lowest. No, we don't have any numbers. Well, you tell me, what do we have under any bars there? X. Yeah, the only thing that's under a bar is that X. That's the only denominator in this problem. So he is the LCD. You tracking with me, right? Like it says, one of each type of letter. So that's it. So that's the LCD. Okay, so the LCD is X. LCD is X. And what do you do with the LCD? LCD over 1, multiply LCD over 1 to all the terms. In other words, X over 1 here, X over 1 there, and X over 1 there. Does that make sense how I arrived at that? I just identified the type of question, followed the steps. X over 1, X over 1, X over 1. Okay, and what do we do now? Cancel all denominators. There's only one denominator. That one cancels out. Okay, so great, but so what does that leave me then? What happens right here? What is X over 1 times 40X? Good, because that X over 1 is just X, huh? So it's, 40X squared exactly. Minus, what happens right here? Just 39X, huh? And what are we left with on the right side? Just the 40, because the X's have canceled. That was the purpose. He's a hitman. He took out the denominators, didn't he? Much nicer now. No more fractions. That's what you do anytime a fraction rears its ugly head. You take it off, right? You take it off with the LCD over 1. LCD over 1, LCD over 1. You get them out of there. All right, you know what to do now? Now it fits a different setup. Look on the board. Look back to the notes. Now it's a what kind of question? X squared. Now it's an X squared question. And we have a game plan for that. We change gears now. Now we go, oh, X squared. X squared. Yeah, what do we do for X squared? First step, get a 0. And then factor, right? Can you do that? Jump in. Time is running. So now for x squared, step 1 is get a 0. So it's like we change gears. Get a 0. So what am I going to do to get a 0? Subtract the 40 from both sides, huh? Exactly. So it'll become 40x squared minus 39x minus 40 equals 0. Sorry, I didn't do that too well. Let's try again. 40x squared minus 39x minus 40 equals 0, because these cancel, huh? Equals 0. Okay. Step 2. So we got a 0. Step 2 with x squared. Factor. Well, how do we factor? First step in every factoring question, what do they have in common? Is there a number that goes into 40, 39, and 40? No. You can try it in your calculator. Nothing's going to go in. They don't all have an x. So we go right to the 2 parentheses, don't we? Now, this is kind of a harder one, I think. So you're looking for 2 numbers in the front that, remember, it's all about multiply. Multiply to be 40. What times what is 40? 5 and 8, 4 and 10, 2 and 20, 1 and 40. How do you know which ones? A lot of numbers multiply to be 40. It's usually, not always, it's usually the numbers closer together. Closer together. I'm just telling you how they make these problems up. 5. So when I think about 40 over on the side and use my calculator, I'm thinking 5 times 8, 4 times 10. Yeah, which pair of numbers is closer together? 5 and 8, right? So it's now no guarantees, but usually they do it that way. 5 and 8. So I'll do that. Let's go back. 5x, 8x. It doesn't matter what order. You put the 8x first, then the 5x. Doesn't matter. But when you put the back 2 numbers in, it will matter. Because then somebody's going to be with a 5x and somebody else is going to be with an 8x. And that will matter at that point. All right, so now for the back, now we're going to say the back number times the back number multiplies to be 40. What times what multiplies to be 40?
8 and 5.
Yeah, 8 and 5 again. Now, like I said, the order matters now for the back numbers. Now, could it be this way? Could it be 5 here and 8 there? I don't know if I've said, I don't remember if I've said, you're never going to have 2 numbers in the same parenthesis that have anything in common. It can't be 5 with 5. It can't be 8 with 8, because you're never going to have 2 numbers that have anything in common, let alone the very same number. Not going to happen. It won't work. You can try it. It just won't work. So maybe it's 8 here and 5 there. Is it? Yeah, it turns out it is. The only way you're going to know is foiling it. And that's what many students don't feel like doing. They're like, really? I got to? You really got to. And the more you do it, the better you'll get. It's just like exercising or anything else. No pain, no gain. If you don't foil these out and foil and foil and foil and foil the hours of your life away, you won't be able to do this. Am I being clear enough to it? So yeah, you got to just try it. So now what signs might we need? Well, the sign in the middle is negative. Well, how do you know? What's the rule there? The sign in the middle goes on the bigger. Who's the bigger? The 8 gets the negative, and the other one gets the positive. Probably. In fact, it is true. Let me check it over here. This is what I mean by foil it. You just got to check it. It's not going to help to just look at it. You got to actually do it. And the more you do this, the better you'll start seeing these things. So if I take that 5x to both, it's going to be 40x squared plus 25x. And then I take the minus 8 to both, going to be minus 64x minus 40. Now, take your calculator. What's 25 minus 64? It's minus 39. It's beautiful. It works perfect. That's exactly right. So the more you do that 2 things with 2 things, pretty soon you'll just start to see them, and you'll be better factorer. All right, on we go. So now what do we do after we have it factored? You factor and you set each equal to 0, right? So then the 5x minus 8 is 0. And the other one, the 8x plus 5 is 0. You have two separate equations, right? Because if two things times to be 0, either one can be 0 to make that happen, right? So let's finish this one up. I'm just going to whip this out here. Add 8 to both sides. So 5x is 8. Last step is usually division. And it is here too. Divide by 5. There it is, 8/5. Other side. Subtract 5 from both sides. 8x is minus 5. Last step to get x alone. Divide by 8. Boom. There's our two answers. What are they? 8/5 and minus 5/8. Separated by a comma. There we go. So those are tough problems. Those are definitely tough problems. Questions I can answer. So there we go. So take a look. The first step's the most important. That's your identification. So identify it. What type is it? It's on the board. What type is it? And take the appropriate step. So step one, we're going to do LCD over 1. The LCD is x times x minus 4. You need the solo x, and you need the x minus 4 glued package. Remember, plus and minuses glue things together? So you need x alone and the x minus 4 package. You need one of every type of thing that's in the denominators. One of every type. It's like going to the store, and I'm going to go to the store today, and I'm going to buy one of everything. One shaving cream, one bar of soap, one pencil, one, That's what we're doing with the LCD. You're buying one of every type of thing that's under the bar in the denominator. So it's x and x minus 4. And then what do we do with that LCD? Multiply that over 1 over 1 over 1, right? It's always the first step with fractions. With fractions with an equal sign, I should say, right? Here's my dividing wall, my equal sign. Right, so we're thinking left and right, multiply by LCD over 1, LCD over 1, LCD over 1. Take it from there, cross cancel, and multiply whatever's left over. To go back and forth between giving you a chance to work and diving in, but I got to keep it moving here. So x minus 4 is going to cancel, right? Remember what he does, as it says on the board. Multiply by LCD over 1 to cancel all denominators. So what's left over? 7, x minus 3. Oh, and the x. I almost forgot. 7, x minus 3, and the x. Let me stick that in the front with the x. It's just easier to have it there. You can put that in any order. It's just easier in that order. Does that make sense? It's easy to miss that little x I almost did. Plus, and what cancels here? X and x cancels. What's left? 13. X minus 4. What's over here? The whole x and x minus 4 cancel. Just minus 13. Good to there. Much better now. No more fractions, right? First step, LCD over 1. So Hitman takes out all denominators. All right, FOIL it out. Multiply it out. There we go to there. And now our mind should go in a different direction, right? What should we recognize? What should we see there and say, okay, it's this type, I know what to do. What type is it now? It's no longer a fraction. What is it now?
X squared.
X squared. Now we go into the x squared game plan. Right? What do you do when you got x squared and x to the first? Get a 0 factor. So it's time. So our next step is to get a 0, right? Because now we're looking at x squared and x to the first, which means step 1, get a 0. What do I do to get a 0? Add 13. Add 13. Boom. That puts 0 on the right side, doesn't it? Everybody good there? See how I know what step to take next? I'm being directed by those steps I wrote on the board for you. Okay, well, what's left here? Well, then the 7x squared minus 21x plus 13. Isn't that minus, what is that, 8? Yeah, 8x, huh? Thanks. And then minus 52 plus 13, is that like 39 or something?
Yeah.
Minus 39? Just use your calculator. So step 1, get a 0. Step 2, factor. Here we are again. Because it's an x squared. So step 1, get a 0. Step 2, factor. Can you factor that one? First question, what's in common to all the terms? Nothing. They don't all, there's no number that goes in all those. So you go right to the 2 parentheses, right? How you doing on that? Again, is factoring. Remember, we look at front and front to make front. We say, what times what is 7x squared? 7x and regular x. Either order, you could put the plain x first and then the 7x, right? But that's pretty much the only option. It's going to multiply to be 7x squared. Right? You say, what multiplies to be the front? And then you jump to the back and you say, what multiplies to be the back? Use your calculator if you're rusty on 39. What times what makes 39? 13 times 3. Yeah. Now, which way does it go? Should the 13 be here and the 3 there? Oh, yes, actually, but I want to do it wrong at first. So I try to do it wrong just so to show you the worst case scenario. So what if I tried it that way? Turns out it won't work. Now, why do I know that already? Because I have foiled 10 million times, at least a million times probably. I don't know, maybe exaggeration. I've foiled a ton, and I can see it happening in my head. There was a time when I couldn't even do it when I first learned this material. But I've foiled so many times now that I can just see it happening, and I know which way it's going to go. And, of course, I'm not assuming most of you are there. But you can get there. You just need to spend the time. You just need to foil after foil after foil, and you'll be able to start seeing it better and better. So if you're looking at that going, is that it? I don't know. It's not. And here's what you do. You just check it. There's no shortcuts. You just got to do it. You just got to do it. So boom, boom. Let's try it. 7x squared. And that, what's 7 times 13? She's calculator. It's 91, I think. And then I don't even have signs in yet. Don't even worry about signs. I just got to see if the numbers are even going to work. 3, and then I start with the 3. 3 times x is 3x. 3 times 13 is 39. Can those two numbers in the middle, 91 and 3, somehow make minus 8 in the middle? No way. No way. So what does that mean I need to change? Need to go back. That didn't work. Need to go back and switch this order. See, the order matters. Got to put the 13 there and the 3 there. I'll check it over here on the side because this one will work. So 7x and 3, no, 13. And x and 3, this one will work. So the 7x goes to both. 7x squared plus 21x, and the 13 goes to both. No signs. There's no pluses or minuses yet. 13 goes to both. 13x and 39. Now, can the two middle numbers somehow make minus 8 in the middle? Yeah, right? Take your calculator. 21 minus 13 is indeed 8. So 21x minus 13x is 8x. That's right. So what does that mean? The 13 needs to be negative, and the 21 needs to be positive, right? The 13 needs to be negative, and the 21, which is 3 times 7, needs to be positive. See how that's right? So that just takes hours and hours and hours of practice. All that. Question, Dalton?
Yeah, going on
I appreciate you pointing that out. Yes, so this should be the other way, shouldn't it? Fix all these signs. Thank you. Yeah, it's supposed to be negative 8, huh? So it's got to be, yeah, so the sign, I forgot my old sign in the rule middle, huh? The sign in the middle is negative, so the sign on the bigger needs to be negative. So negative on the 21 plus on the 13 makes negative 8, so minus on the 21 plus on the 13, so minus plus, like that. Now that's a little tricky. You might, you know that rule I gave you about sign in the middle, sign on the bigger? It's really only true for the final thing, like the 21's got to be negative. Because you might look up here and go, Mr. Aaron, no, your rule's not true, because the minus ends up on the smaller one. Well, that 3 is technically the bigger one than 13. What, how's 3 bigger than 13? Because he ends up hitting 7 to make 21. So it's just more advanced at this point. I try to give you whatever shortcut rules I can to help, but the truth is you got to just foil and foil and foil and foil. That's really it. So you foil it, you see it. Thank you for the correction. So that should be, what is it? Plus 13 minus 3 is the correct factoring. And now we set each one equal to 0, right? Right after we factor, they each get their own 0. So the first one, 7x plus 13 is 0. The second one, x minus 3 is 0. Then we just solve it. And then you subtract 13. You know the drill here. 7x is minus 13. Divide by the 7. There's the first one. The other one, add the 3. So x is 3. So the answers are minus 13 sevenths and 3. 2 answers. And foil it and foil it. So if you just foil this out, you'll see it really does go back to this correctly. So that's the main answer. Just foil it out. First to both, second to both. And you'll see that. So I'm glad to do those with you in office hours. Anthony is glad to do that, but you have to. On 19. What should we do on 19? Look at that one. What should we do?
We gotta take out one of the x's.
Beautiful, beautiful. Yeah, so again, it's the, I don't really have an x cubed on the board, but it's the same thing as x squared. You basically got to get a 0. They've already got that for us. So it's basically the same strategy as those other x squared ones. So step 1, get a 0. It's already there for us. Step 2, you got to factor in. Yeah, good job. Exactly right. We need to factor, like Lashani, right? Like Lashani's saying, you got to factor, and notice they all have an x in common. She's exactly right. So, right, they all have an x. So you got to do that first with the one big parenthesis. Right? You got to take out that x, one big parenthesis, and then on the next step, we'll go to the 2 parentheses. Remember this factoring? So take out what's in common first. So GCF first. And what does that leave in the inside? Whatever works. X times x squared will go back to x cubed, because there's an invisible 1 power on that x, huh? That'll add back. X times minus 12x, the 1 powers will add. X times plus 20 will go back, won't it? Remember taking out the greatest common factor? So we do that first, and that's right. If you multiplied it, it would go back. And then for what's left, we got to do 2 leave that x in the front. But then the 3 terms in the parentheses, we got to break those down to 2 parentheses. And do the same kind of thing we've been doing. Where we go front times front, right? X times x makes x squared. They multiply. And then the back, what times what multiplies to be 20?
2 and 10.
Yeah, good job. We don't want 4 and 5. Because remember, they have to add to be the 12 in the middle, don't they? 4 and 5, because a lot of things multiply to be 20, you know, right? 4 times 5 is 20. 2 times 10 is 20. 1 times 20 is 20. Which one do we want? Yeah, 2 and 10. Because, and what signs do we need on that 2 and 10? Both negative. Right? If you lose $2 and lose $10, you lost $12. That'll make the middle term happy. And the 2 negatives will indeed multiply to be positive 20, won't they? Good so far? Now, where do we go from here? Well, what does it say on the board? After you factor, you set each part equal to 0. What if I told you guys, hey, I'm thinking of 3 numbers in my head? All right, I am. 3 numbers in my head. I times them all together and it comes out 0. What does that mean? Any of the 3 could be 0, huh? Any of the 3. So that first x alone could be 0. The second group, the x minus 2, could be 0. Or the third group, x minus 10. You said any part that has an x. Any part that has an x could be 0. So this one's done. right? Nothing more to do there. X is already alone on that one. How about this one? Well, we need to add 2. So x is 2. This one we need to add 10. So x is 10. So we have 3 answers, 0, 2, and 10. There's 3 answers to that problem. No surprise, it was x cubed from the beginning. So there's 3 answers. Sorry about that. How are we going to do this one? So here again we have an x cubed, same thing as x squared, equal sign. What do we do when we have some kind of x thing with an equal sign? The game plan in general is the same as it is for x squared over here. It's get a 0, try to factor, you know. So we've already got the 0, don't we? We've already got the 0. So step 1, get a 0, done. Step 2, factor. Now, how do we factor? Well, the first thing is GCF. There's usually not a GCF, but it's important that we're always looking for it. Do they all have an x? No, that minus 4 at the back does not have an x. So they all have, is there a number that goes into all of them? No. All right, so there's no GCF. So then what do we do? Is this like the 2 parenthesis kind? No, it's notice it's first off it's not the 2 parentheses because it's 4 terms, not 3. See how I'm always identifying the type. See the way I'm proceeding? I'm looking at what we have and saying, oh, what category does this fit? It's not, look back here. It's not 3 terms. See how this guy was 3 terms in the last problem? And so I, did the 2 parentheses. This is 4 terms. Now, we did those in the homework. And you remember them all perfectly. No, I know it's hard to keep it all together. 4 terms. Remember you do a 2-2 split? You do a 2-2 split. So just the first 2 and just the last 2. That's what you do for 4 terms. That's the thing, math, it never goes away. Huh? Whenever we learn, it builds and we keep using it. So what do you do with the first 2? Well, what do they have in common? Just the first 2. Forget about the back 2. What? X squared, yeah. Just those first 2 have x squared in common. What does that leave on the inside? What's going to work? X squared times x and x squared times 1, huh? Okay, now what about the back 2? What do they have in common? What goes into both them? -4. Correct. And what's going to work there? -4 times what? X and -4, yeah, plus 1. Because -4 times plus 1 will go back to -4, won't it? And see how we got a match? That'll always happen, guys and gals, on the 4-termers. When you do the 2-2 splits, this is what you always do for 4 terms. You do the 2-2 split. So, right, 2 terms split. And then you have to keep going. Remember when you see how these both have an x plus 1? This is a little tricky, but let me remind you. What if you had x squared w minus 4w? What if those were your 2 terms? You would look at them and say, hey, they both have a w. And you do what? Put the w in the front, and you'd cross it off, bring down x squared minus 4, right? That'd be what you would do, because that w could go back to both, right? It's just distribution backwards, right? Well, it's the same deal with an x plus 1, because that's just like a big W, right? This is like a W, and this is like a W. Do you see that? It's the same thing. It's just bigger. These 2 terms both have a common element, a parenthesis x plus 1. It's just like having a common W. Same thing. You just put the thing they share in common in the front. In this case, it's the parenthesis x plus 1 instead of a W. Cross it off, write a new set of parentheses, bring down the leftovers, x squared minus 4. Do you see how that's the same thing as if it was a W and a W? Except it's a parenthesis x plus 1, parenthesis x plus 1 that they have in common. Right? Because that parenthesis x plus 1 could go back and back, couldn't it? All right? Great. Now one more thing. This is a tricky one. So what can we do with this? This guy, now why am I even looking at him? Because of that squared. Whenever something has a higher power, I give it a second look. And I think, maybe that'll break down again. Maybe not. Maybe it will. Can we break that down again? Yeah. So the x plus 1 is done. But he's still part of the deal. He's just not going to break down anymore because he's just regular x. He's not x squared. But yeah, the other guy, how does the other guy break down?
X minus 2, x plus
Yeah, remember that? We called it a difference of squares, right? I call it a double-double sometimes because this is x times x, 2 times 2. It's a difference of squares. It's a double-double. X plus 2, x minus 2. Either order doesn't matter. Yeah, so I take it back. It did end up being 3 parentheses in the end, didn't it? When all was said and done. Somebody said that early on, right? Okay, right. You were right. In the end, it was 3 of them. All right, anyway, what do we do now? Now we got all the factoring done. And what do you do after you factor? Try to factor and set each one to 0, right? Because they're all timesing to be 0. So if a bunch of things are timesing to be 0, any of the 3 could be 0 to make it all multiply out and be 0, huh? So the first one can be 0. Whoops, kind of scribbly here. So the first one can be 0, the second one can be 0, or the third one can be 0. And then we just solve them each, right? Subtract 1, add 2, subtract 2. There's our 3 answers, -1, 2, minus 2. Any order, you can put those in any order. Math Excel wants all 3. Again, look, in x to the third power, 3 answers, huh? We should expect 3 answers when we see x to the third power. Questions on that one? Okay, so, all right, so here it is, big old powers again, right? So what's the first thing you do when you got these big old power ones? Get a 0, huh? First step, get a 0. Hey, how about I give you a shortcut now? You want a shortcut? I hesitate to do this. I hope it doesn't confuse you. But basically, how are you going to get a 0? So first step is get a 0. How are you going to get a 0? What's going to get you a 0? Minus the x squared and minus the 147. Exactly. Because that'll cancel and put us 0 on the right side, which is what we need. And whatever you do to one side, you have no choice but to do the same thing to the other, right? To keep the balance. Right? We got to treat them the same. Well, here's the shortcut. You could do that, and that's great. Notice what ends up happening. Basically, when you could have just jumped them to the other side and switched their sign. That'll have the same effect. Do you see what I'm saying? Right? Do you see how this x squared ends up on the other side but negative? And the plus 147x ends up on the other side but negative? So really, I could have just jumped it, and just switched the signs. That's what ends up happening when you do the same thing to both sides and you get a 0, and it just always ends up jumping to the other side and switching the sign, right? You see? So that'll save you a little bit of time. You can just jump something to the other side and switch its sign. So now, how do we write them on the other side? Well, it's got to be in order from highest power to lowest. So 3x cubed minus x squared minus 147x plus 49. So I went highest power to lowest. So I got them there. So you know what to do now. 4 terms, right? 2-2 split. First 2, last 2. Can you do that? Okay, so for the first 2, we take out x squared. Is that good? Right? Because if that x squared multiplied, it'd go back correctly, wouldn't it? And then the back 2, I'm saying 49. But the front is negative, so you go negative 49. And that leaves 3x minus 1. See how they match? Remember I told you they would always match when we do 4 terms? The parentheses will match. See how that's correct? Now, see what we do? It's like the W thing, right? Pretend this is a big W and a W. They both have the same common parenthesis 3x minus 1. So what do you do when 2 terms both have the same common element? you pull it to the front. Pull it to the front. So parenthesis 3x minus 1 to the front. And that leaves behind, cross it off, bring down the leftovers. X squared minus 49 equals 0. Is that good? See what happened there? See, that whole 3x minus 1 could go back and back, couldn't it? So it's, it's the same thing. So this is just like that last one. And then what do we do from here? Where should my eyes go? What should I look at and think about further?
X squared.
Yeah, that x squared. Right? I think, ooh, can that break down again? Because that's a higher power. I don't even think about the 3x minus 1. That's just regular x to the first power. That's not doing anything. He's done. But that x squared minus 49, what's he? X plus 7, x minus 7. It's a difference of squares again. It's a double-double, isn't it? So we have 3x minus 1, x plus 7, x minus 7 equals 0. And now that we got it all factored, you set each one equal to 0. I'll bring them over here. So the first one, 3x plus 1 is 0. Or the second one, x plus 7 is 0. Or the third one, x minus 7 is 0. So you have 3 of them equal to 0, right? Because if 3 things multiply, coming out 0, any of them could be 0. Can I save some time here? I'm just going to jump that 1 to the other side. What will happen when that 1 jumps over the equal sign? It'll become -1. Just to save some time. You can just jump something to the other side of the equal sign, and it just saves time. I just subtracted 1 from both sides is really what I did, you see. See how that's the same? It's just a shortcut. And then divide by 3. So we got one answer. And then the 7, just jump it over. -7, right? -7, jump it over. +7. It just switches their signs, huh? When you jump something to the other side of the equal sign. So we got 3 answers. -1/3, -7, regular 7. Questions I can answer. Number 22. All right, we're going to change gears a little bit. X minus 3 squared is 81. X minus 3 squared is 81. So what we're doing now we're going to go, I'm going to go back and find where I wrote it. Let me go back and back. Oh, here it is. So on the solving x squared part. So we have some that are x squared and regular x. But some of them are x squared and no x to the first power. Or x plus a number squared. Same thing. And what do you do in that case? You get the x squared alone, and you go root and plus or minus root over the sides. So this will be nice. This will be easier. This will be like 2 steps, most of these. But you got to recognize it. The battle is recognition a lot of times. See, it's right here. So, okay, what am I talking about? What are we trying to recognize? Let's see. As you look at this, what needs to jump off the page for you is you need to look at it and go, oh, I have x squared, but, well, here. No, not number 1. X squared, but no x to the first. That's what needs to jump off. But you see, there's an x squared. What do you mean? Well, that x is under the influence of a square, isn't he? He's effectively an x squared. Now, I know probably a lot of you are thinking, well, shouldn't we write 2 of them and FOIL it all out? You totally could, but that would be way harder. I'm going to show you a way to save a lot of work. That's right. Of course, that's legal. There's nothing wrong with that. It's just way harder way to do it. So here's what we're going to do instead. So first off, you have to recognize that this has x squared only and no x to the first. You might think, well, yeah, but that's x first. No, he's under the influence of a square, right? So he's effectively, really, an x squared. Now, look back, well, it's been a while, but if you look back to some of these other ones, we had, like right here. See, we had, back in 16, we had x squared and we had regular x. So those are the kind we had to get a 0, and right, we got a 0, and we had to factor and all that. Well, these are quicker. This one's going to be quicker because it's only, I kind of messed it all up now, let me rewrite it. It's only x squared, x minus, what was it, 3 squared is 81. So it's only squared, no x to the first power. Okay, so as soon as you recognize that, what do? Step 1, you get the x squared piece alone. It already is. It's already, the x squared thing is already alone. So that's effectively done. Okay, so then what do you do on step 2? Step 2 is you put root and plus or minus root. So you put a root over this side and a root over that side with a plus or minus. Why? Because rooting is the opposite of squaring, isn't it? A root cancels out a 2 power. They're the opposites. Now, I don't want to just say it. Let me prove it's true. Think about, for example, the square root of 3 squared. You guys know what that is, right? What's 3 to the second power? 9, right? 3 times 3, right? 3 squared means. And what's the square root of 9? Just 3. See what ended up happening? These guys canceled, and it was just a regular 3. That's just an example to show that the roots and 2 powers are opposites of each other, aren't they? They're like a poison and an antidote. What are you supposed to do if you swallow some poison? You're supposed to swallow the antidote, right? Then they just neutralize each other in your stomach, right? Well, that's what a 2 power and a root do. They're opposites of each other, so they neutralize each other and they're both gone, aren't they? Right? The root and the 2 power, and just all you got is plain old 3. Oh, so as soon as we see this 2 power, we think, oh, I can get rid of that. Just throw a root over it, and it'll neutralize it. But whatever you do to one side, you have no choice but to do the same thing to the other, right? That's called the principle of equality. If 2 things are equal, treat them the same, still be equal, of course. Now, you might say, well, wait, but you did something different to the other side. Yeah, and let me tell you why that is. I'm going to give you the reason for that. Just think logically with me about a simple question like x squared is 9. Now, forget about all the fancy math rules for a second. Just pure logic. What could I plug in there squared and it'll come out 9? I actually have 2 options.
3 and negative 3?
Yeah, 3 or negative 3. Negative 3 will work also, won't it? Negative 3 squared, negative 3 times negative 3 is also positive 9. And of course, 3 times 3 is 9. So my point is, there's 2 answers, right? Okay, so what? Well, let's go back and solve it again. If I solved it using this root technique, the antidote that I'm telling you about, if I put a root there, and I put a root there, and I don't put a plus or minus, do you see I'm only going to get one of the 2 answers? Right? This will cancel, and what's the square root of 9? Only 3, but we know better. We know really negative 3 is also an answer to that equation. In fact, it's squared. It's got to have 2 answers. So what do? You put plus or minus. That way, that plus or minus is just shorthand for both positive and negative 3. It's just a shorthand way of writing it. It means 2 answers. Why? Because it's true, huh? Just look at it. X squared, 3 or negative 3 works. So when you put a root on both sides, you got to put plus or minus. Now, my job as a math teacher is to help students succeed in math, and this has been a stickler point for many, many students for many, many years. Well, so it was only after a couple of years of I always tell them, but then on the test they forget to put the plus or minus because, it's just natural just to put the root, forget the plus or minus. So I made up a really dorky saying to help. That's what I do. This is my dorkiest one. So if you put a roof on the house, that's my root, sorry. Put a roof on the house. How are you going to get if you need a new roof for your house, what do you got to do? You got to go up and down the ladder. That's my plus or minus. Sorry, it's reaching. But ever since I started saying it, it helped. More people got it right, so I've stuck with it for years now. So again, if you put a root on both sides, which is what we'll do here, you've got to go up and down the ladder, plus and minus, when you put a new roof on your house. All right, so remember that. When you put a root on, you can't just do root. You got to do plus or minus on the right side. Because it's true, as we just saw. Okay, getting back to the problem then. So, what we do when we have a 2 power is we root both sides. The rooting cancels the squaring because they're antidotes. And so all we get then is x minus 3. And we have the plus or minus. And what's the square root of 81? 9. Now you got to write 2 of these though. Because it's plus 9 or minus 9. So it actually becomes 2 equations. Everybody see what happened
Oh,
there?
we don't put it in the root with the plus.
Good question. Yeah, what happened? Well, this root was canceled by the 2 power, so he ain't there anymore. The other root, we did the root. The root of 81 is 9, and the root is gone. When the root does his job, then he vanishes. So the root of 81 is 9, and the root's gone, because he did his rooting. So that's a good question Angie's asking. Does everybody see that? That's why there's no more roots on the scene. The one on the left side was canceled out by the 2 power, so he ain't there anymore. The one on the right side did his rooting thing and left. So now it's easy, right? Now just add 3 to both sides. Now that we got rid of the powers and all the weird stuff, add 3 to both sides. This would be minus 6. There's my 2 answers, 12 and minus 6. So I talked that one out a lot. It's really pretty quick. They'll just be like 2 steps, and we'll be there. Questions on that one? By the way, can you see those are really right? I like when we can, we have a moment. We don't have many moments. I like to go back and just check. Those are really right. Let's see it. If you put a 12 back in here for x, when we say x is 12 or negative 6, we're saying both those work. Both those make the original equation true. Do you see it is the case? What's 12 minus 3? See, I put the 12 back in here. I'm just checking. Not required, not required. But if you just put that 12 in for x, what's 12 minus 3? 9. And squared? Yeah, 81, right? No, okay, that works. But what about the negative 6? Does that really work? Negative 6? Minus 3? What's that? Negative 9 squared, 81. Isn't that beautiful? How did the equation know that would do it? It was all this logic. We used perfect logic. That's what separates us from the beasts, right? We use logic. All right, let's go on. So 23. So 2y plus 5 squared equals 25. So try the same thing. It'll really be pretty quick. So when you see a squared, what are you going to do? Root both sides, right? Put a root right away. First step. Just root over the left, root over the right, but don't forget to go up and down the ladder. Plus or minus on the right side. So root over the left, over the right, plus or minus. So on the left side, the rooting cancels the squaring. So it's 2y plus 5. And that's going to be 5 or, remember, it breaks into 2 equations. Negative 5. Everybody good there? It's 5 or negative 5. See how those 2 options for the plus and minus on the right side? And there's no more roots, because the root of 25 is 5. When you do the root, it leaves. So finish them from there. Get y alone. Now that all the mess is gone, it's pretty easy from there. So y said I want to be alone, so subtract 5. 2y is, what's that, 0? Don't let that bug you. Just keep right on moving. Y said I want to be alone, so what do we do? Divide by 2, right? Last step's almost always dividing. And what is 0 over 2? What if you have no candy bars and you divide it among 2 people? They get nothing. Half of 0 is just 0. All right, and then the other one. Y wants to be alone. Subtract 5 from both. Cancels. 2y is minus 10. Last step. Divided by 2. Y is minus 5. The 2 answers are 0 and minus 5. Again, x, we had squared power. We got 2 answers. You see in the pattern, right? Third power, 3 answers. Second power, 2 answers. There we go. Questions on that one? Okay. Something big brand new is going to be here. Okay, so x squared. We've been doing that for an hour and a half or whatever. What do we do first with x squared? X squared. Oh, this one is x squared and regular x. We're back to x squared and regular x, aren't we? So when you see x squared, so step 1, so the identification, we'd say, okay, this is one of those x squared and x to the first. Step 1 is get a 0, but we've already got that. So that's nice. Step 2, try to factor, right? Now, I don't know if you noticed that I don't just say factor on step 2. I say try to factor. Here's why. Here's the case in point. If we try to factor this one, it won't work. You can't always factor, right? Look at the numbers there. X is in the front. What two numbers multiply to be 14 and add to be 2? What times what's 14? 7 and 2, 2 times 7, or 1 times 14. There's no other options, huh? It's got to either be 2 times 7 or 1 times 14. Which of those add to be 2? Yeah, neither of them. It doesn't factor. It doesn't factor. So we give up on the factoring. What do you do when it doesn't factor? The quadratic formula. So, or negative b. In fact, let me just write it over here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's what we use. That's called the quadratic formula. Quadratic formula. And it'll solve any x squared equation. It's the x squared solver. You can use it all the time if you want to. It's usually, factoring is usually quicker if things factor. But anyway, let's do it. So, okay, definitely want this on your 3x5 card, right? You're seeing the things you need on your 3x5 card for the exam coming up, right? Is you need, these steps I'm giving you, and then like that formula. All right, anyway, so what do you think the A, B, and C are?
A is, B is that x squared, A is this x. And
Just goes in normal order, just A, B, C, normal order. So A will be x squared. B will be the next one, C. Yeah, just normal order. So in other words, A is whatever number's in front of x squared. What number is in front of x squared? Well, 1. It's like a 1 is there, right? Because 1, if there's nothing there, there's really an invisible 1, because 1 times x squared is the same as x squared. And next, it comes B and then C. So B is the 2, and C is the negative 14. So the A, B, and C in the quadratic formula, the first, second, third, numbers. It's not the x's. You just grab the number in front of the x squared, which in this case is 1. The number in front of the x and the other number. And then you plug them in to the quadratic formula. Now notice the quadratic formula has some built-in things of its own. Like it's got some built-in minus signs, it's got a 4 and stuff like that, right? And by the way, also notice this bar goes all the way across. Common mistake is students will only have the bar under the root part. That's not true. The bar goes all the way, and that makes a difference. Here we go. Negative b, well, b's 2. Plus or minus the square root of b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is minus 14, all over 2 times a, and a is 1. So I plugged it all in, and now we just crank it out. So,
You have to put it parentheses, yeah.
right here. Yeah, it's helpful. Whenever you plug into a formula, it's a good idea to put parentheses.
Okay.
It just makes things easier to work out. So, okay. So negative 2 plus or minus. Now, what happens in here? What is 2 squared? 4, right? Now, one of the spots, this is actually pretty easy for students. Most students do this thing very well. One small area that sometimes gets people is the sign here. The easy way to deal with that is just count your minuses. You have a minus, but that minus is really on the 4, right? That's his baby. Minus times plus times minus. So what's the sign going to be? Positive. 2 negatives, right? Negative, positive, negative. 2 negatives, positive. So if you had 3 negatives there, it'd be negative. If you have 1 negative, it'll be negative. 2 negatives, positive, right? So this will be plus, because it's negative, times positive, times negative. And then use your calculator. 4 times 1 times 14, was that 56? 56. All over 2 times 1, which is just 2. See how that became positive? 2 negatives? Okay. And so what is that then? Negative 2 plus or minus the square root of 60 all over 2. Or we get to there. Now, what in the world do we do with the square root of 60? Do you remember your square root rules? We're actually going to be doing that next week, a whole review on that. But let's begin right now. Square root of 60. How do we do it? We break it down with a factoring tree. Have you seen this before? On that? So what times what is 60? There's a lot of things. With a 0, I just always put 10. But you could do 4 times 15, 2 times 30, whatever. Doesn't matter. It'll all be the same in the end. Doesn't matter how you get there. So, but I always think of 10 when a number ends with a 0. So 6 times 10. But keep going. The 6 can break down again, huh? What times what is 6? 2 times 3, 3 times 2. What times what is 10? 2 times 5 or 5 times, either way, or doesn't matter. Can I break those down further? No, those are, what kind of numbers are those? Numbers that don't break down further. Prime numbers. Those are primes. Anyway, I'm not going to quiz you on the name, but prime numbers. They won't break down, so that's it. That's as far as we go. Okay, so what? Well, that means the 60 is made out of these 4 pieces. That's like the DNA of the 60. That's the DNA that makes up, the little pieces that make up the 60. So that's like 2 times 2 times 3 times 5. I put them in order, just for ease. And you could double check that in your calculator. 2 times 2 times 3 times 5. It will be 60. It's the guts of a 60. Okay, so what? What do we do now? What's all that about? How do square roots work? Does anybody know? How do you simplify square roots? We haven't been over it, have we? I'm not forgetting. Square roots are a 2-for-1 deal. I haven't said that yet, have I? Square roots are a 2-for-1 deal. 2 2's in, sends 1 2 out. What am I talking about? Let me show you on a separate page for just a second. What's the square root of 9 again? You know that one, right? It's 3. Think about what just happened there. What was in that 9? What times what was the 9? 3 times 3. So how many 3's did we have?
2.
And how many came out? Look at that. Square roots are always taking 2 of something, 2 3's, 9, 2 3's, and sending 1 out. They're a 2-for-1 deal. They're like shopping at Target. Things are on sale 2-for-1, right? That's what square roots do. You ever stay up late at night and play around with square roots and go, oh, they're 2-for-1. Look at that. No, that's what weird math teachers do, huh? All right. So, yeah, but they always do that. That's it, right? Think of any, like square root of 25. What is it? 5. And what was in there? 2 5's. 2 in, 1 out. Okay. So that's what square roots always do. They're a 2-for-1 deal. So then get back to the problem. 2 2's inside, 1 2's coming out, and they're gone. Right? Like we saw already. That's the pattern. That's what square roots do. They're a 2-for-1 deal. Okay, so what is this? So square root of 60 ends up being 1 2 on the outside. And then what's left on the 3 and the 5, they cannot come out because there's not 2 3's, there's not 2 5's, so they're stuck in. And you just go ahead and remultiply them. 3 times 5, 15. And so the square root of 60 simplifies to be 2 root 15. That makes sense? It's a 2-for-1 deal. It's all square roots do. Okay, let's get back to the problem then. So this is negative 2 plus or minus that root 60 becomes 2 root 15 all over 2. Okay, so now what? What can we do? Well, remember, can I just like cancel these 2's? You'd probably tell from my tone you can't. But why not? Why is that wrong?
Because it would have to have the thing 15.
Costco says no, right? Remember we talked about plus or minuses? I'll keep beating that drum. That'll help you in a million situations. Remember, pluses and minuses are like shopping at Costco. That means things are packaged together. You have to buy the whole package or nothing, right? That's how it works at Sam's Club, Costco, those warehouse stores, right? You can't buy just one. That's what plus or minuses do in algebra. They glue things together, making them a package deal. You can't say, I just want that 1 2. I just want to cancel this one guy. No, he says, no. I'm glued to this other guy. You got to buy the whole package, right? That's what Costco says. You got to buy the whole package or you can't buy anything. Well, we can though. We just do that one also. And that's correct. But you got to do them both. You got to buy the whole package. So the answer then is minus 1 plus or minus square root 15. Those are actually 2 answers. Here's how you put it. Well, Math Excel will let you put it in just like that. But if you want to see it separate, it's this and that. Because that plus or minus is just shorthand for two separate answers. And there it is, we're done. Do you see what happened there at the end? So that 2 on the bottom canceled both those 2's because they're a package deal. Right? They're shopping at Costco, they're a package deal. So you buy them both. 2 goes into 2 one time, 2 goes into 2, and that's a -1. Now you might say, where'd the other 1 go? Well, 1 times root 15 is just 1, so I didn't even write it. Right? This is 1, and this is 1. And there is technically a 1 there, but who cares? 1 times root 15, that's just root 15. Nobody leaves 1's multiplied next to a number because they do nothing. Right? You with me on that? So we don't write that 1 next to the root 15. The other one matters. Am I losing you on that? Does that make sense? If I take 7 and I add 1, does that 1 matter? Does he change the number? Yeah, now it's 8. That 1 matters. But if I go 7 times 1, does that 1 matter? Does he change the answer? No. So he's ridiculous. And we don't put him there. So numbers multiplied by 1, we don't write the 1 because that doesn't matter. But numbers, when you add or subtract 1, that matters. That must be there, right? So that's what happened back here, right? This 1 is just multiplied. He's not doing anything, so I didn't write him in the final answer. But the other 1 matters because he's added, subtracted. And there we go. Yeah.
So you have to write it like that.
They'll take it just like this.
Oh, yeah?
Yeah.
Okay.
Either way. Is that good? Does that make sense?
Yeah, it's kind of,
Angie?
how'd you get the 1?
1, yeah, okay, let's backtrack. It was kind of fast. Let's go back and do that again real quick. It'd be worth it. So yeah, so going back here, so we had the, we had minus 2 plus minus, and that root 60 became 2 root 15. So 2 root 15 over 2. Now, what I did at this point is I divided. I went 2 goes into 2 one time, right? 2 divided by 2 is 1. But it has to do the other one too because of the package. 2 goes into 2 one time, but the negative is there as well. So it's a -1. So it became -1 plus root 15 and -1 minus root 15. Those 2 separate answers. Like that. Or you could just put the plus or minus in the middle. That's okay too. Is that good? Now let me expand that a little bit. About that thing that just happened with the root. Let's go back. What if we had -3 plus or minus 2 root 15 over 2? Or actually, I keep changing my mind. Let's make this a 4. What if this was -4? Now, in this case, the 2 could go into 2 one time, and the 2 would go into 4 2 times. And the answer would be -2 plus or minus root 15. Again, you don't need that 1 next to the root 15. It's not doing anything. Okay, but wait a minute. What if it was a -3 instead of a 2 or a 4? What would be the case now? Track with me. This is important. This will come up. What's the deal there? So does this 2 go into that guy and that guy evenly? No. It doesn't go into 3. So what does that mean? Can't do anything. Done. Remember? Because you're shopping at Costco. If you can't buy the whole package, you can't buy anything. We can't. It doesn't go into both, so it doesn't go. It's all or nothing. It's a package deal. So if it doesn't go into one of the 2, it doesn't go. It just stops right there. Does that make sense? It's got to be able to go to both. Here's the version that sometimes tricks people. Or let's make that a 4 again. People will look at that and they'll go, oh yeah, I can do it because the 2 goes into the 4 and there's no number there, so it's okay. There's only one number and it goes in. No, there's not only one number. What's really invisibly in front of that root? There's really a 1 there, and 2 doesn't go into 1, so you're done. You can't do it. Does that make sense? There really is a second number there. If there's nothing, there's a 1. So it has to go into both or nothing. It's a package deal. Plus or minuses package things together. So many rules, huh? There's a lot of rules. All right. So let's try number 25. 25. So x squared minus 6x minus 5 equals 0. Let's try that one. It looks like it factors, huh? It really doesn't. Bless you. You could try it. It looks so close, like 5 and 1. It looks like 5 and 1. They'll make 6 in the middle, but the signs just won't quite work. It looks so right. Like you could go -5 plus 1. That'll multiply to be -5, but that won't add to be -6, will it? The only way they're going to add to be -6 is if they were both negative, right? Then lose $5, lose $1. That'd be the middle, but then that wouldn't multiply to be -5 at the back. It just doesn't factor. It's an illusion. It's a mirage. It looks like it's going to factor, but it never quite works. Anyway, quadratic formula. You got to go on to the -b plus or minus the square root of b squared minus 4ac all over 2a. It will not factor. So go on to the quad it. Take it from there. Plug in the a, b, and c. A, b, and c are the numbers in front of x squared, x, and no x. And they're just the numbers. They're not the x's themselves. So a is just 1. B is just the -6, not the x. And c is just the negative. Yeah, so Faith had a good question. So notice it's negative b right there. Right? So that's negative whatever b is. And b itself is negative. It's going to end up positive, isn't it? Everybody see that? So in other words, there's a negative sign from the quadratic formula, and then there's also a negative sign that comes from the equation from b. And so the two negatives will end up being positive, won't they? You can do it in one step or two or whatever you want. But yeah, that's exactly right. Faith has it right. That's what we do. So right, guys, notice I put parentheses around the numbers I plugged in. That's important. That's important. See right here, this -6 has parentheses around him. So -6, so it's going to end up being positive 36, isn't it? Not negative. Well, why do we have to put parentheses? That's the only way to be true to the meaning. What do I mean true to the meaning? Well, it says you're supposed to do b squared here. What is b? B is -6. So b squared means b times b, doesn't it? Of course it does. So the only way to be true to that is to put parentheses around it. That's the only way to really do b, all of b squared. If you leave off the parentheses and just write it like that, you're not really doing all of b twice. You're doing 6 twice and only 1 negative. That wouldn't be true to what the formula said to do, right? All of b twice. All right, so long story short, if you didn't follow with all that logic, it's all right. Use parentheses, and you'll be in the truth. So use parentheses. So, all right, so what do we got here? 2 negatives, positive 6, plus or minus the square root of positive 3. Now remember, look at your signs. Negative, positive, negative. 2 negatives, positive 20, all over 2. Everybody see what happened there with the signs? 1 negative, 2 negatives. 2 negatives becomes positive 20 down here. And then that's 6 plus or minus the root 56 all over 2. We good to there? Now, you need to take this 56 and use your calculator and break it down. Break it down on your calculator. So break it down with the factoring. Okay, so this is, usually just use your calculator. 7 times 8, 2 times 4, 2 times 2. Now, we're only going to use the numbers that are at the ends of the branches, right? The numbers that didn't break down anymore. So like, I'm not going to use the 4, for example. He's not there anymore. He broke apart into 2, 2. He's represented in the 2 2s, right? Does that make sense? So you're only going to use the 2, the 2, the 2, and the 7. Just the things at the ends, because those are the things that can't break down anymore, the primes. So we're finding the prime DNA, the fundamental building blocks that make 56, the primes, the numbers that won't break down anymore. So what does that give us? It's the square root of 2 times 2 times 2 times 7. Is that making sense? And now we're going to do a 2 for 1. Right? Because that's what square roots do. 2 in, 1 out. 2 2's in, 1 2 out, and they're gone. So that's a 2 on the outside. What's left on the inside that couldn't come out? 14. 2 times 7. So it becomes 2 root 14. Root 56 is 2 root 14. Everybody seeing that? See what happened there? So you got to break apart that 56 into all his little primes that won't break down anymore. And then 2 for 1, ship it out. So it's 2 root 14. So this becomes 6 plus or minus 2 root 14 over 2, right? The root 56 became 2 root 14. How are we doing? We good there? Is that making sense? And now, can we simplify that any further? We're shopping at Costco. We got glue there, but it's fine as long as we do the whole package. That's a 3. That's a 1. So we get 3 plus or minus 1 root 14. And that 1 is not doing anything. So we skip it. There we go. Those are 2 answers. 3 plus root 14, 3 minus root 14. Math will let you type it in just like that, though. Does that make sense on that? All right, so 27. So I'm skipping a little bit here, 27. How do we solve 27? Think about the categories we've learned. They're on the board still. Which category is that? It's x squared, but remember, x squared had 2 different types. Which type of x squared is that? Does it have an x to the first power anywhere? No. So it's x squared with no x to the first. So follow those steps. See if you can do that. We're not going to do quadratic formula. Notice there's no quadratic formula under x squared with no x to the first. This is easy. This is a 2-stepper. See what you can do. So I'll go back to those instructions. There it is. Yeah, it's this right here. X squared with no x to the first. There's what we do. Okay. Okay, so x squared with no x to the first. What do we do? Step 1. What's first step? Get a 0? No, that's when you got x squared and regular x. You don't get a 0. What do? Get x squared alone, right? That's the first step it says. That's why it's so important that you identify the type and follow the steps. Otherwise, the very first step is different. Get x squared alone. Okay, well, here's the wall. How do I get x squared alone? Yeah, I'm going to take the shortcut and just jump it. But yeah, subtract 49, jump it, whatever, same thing, right? And what does that give me? X squared equals minus 49, right? When it jumps to the other side, it switches signs, or you can just subtract 49 from both sides, same effect, whatever. Good to there. And now step 2, root and plus or minus root, right? Go roof on the house, up and down the ladder. So x squared is minus 49. What am I going to do? I'm going to put a roof. Watch this. Something different is going to happen here. A root over the left side, over the right side, including the negative, over the whole right side, and up and down the ladder, plus or minus, outside of the root. It's what we always do when we have an x squared, right? Get it alone, root on both sides, up and down the ladder. Okay, and rooting cancels squaring. They're antidotes. Okay, now here's the million-dollar question. If that was a normal 49, if it didn't have that negative, square root of 49 would just be 7. We all know that. But it does have a negative. What do you do with the square root of negative 49? Does anybody know? What's the square root of 49 again? 7. And if a young child asked you why, how would you explain? Why is the square root of 49 7? 7 times 7 is 49. Right? So then with that thing, right? So it basically says what times itself is this thing. Exactly. So with that same thought in mind, what would be the square root of negative 49? What times its very self is negative 49? You can't do that, can you? Yeah, because you'd have to have one positive and one negative, and that's not times its very self. That's times its opposite. Right? You with me? You can't do the square root of negative 49. There's no number times its very self that comes out negative 49. Positive 7 times positive 7 is positive 49. Negative 7 times its very self, negative 7, is positive 49. How are you going to get negative 49? You can't get negative 49. Right? There's no real way to do that. You'd have to use opposite numbers, and that's not what square root's about. Square root's about what number times its very self. So there's no real way to do it. There's no real way to do it, but we'd like to do it anyway. So let's use our imagination. I'm not fooling around. That's what they did. You know what the answer to this is? It's 7i. And I stands for imaginary. It really does. I'm not playing with you. Have you seen complex numbers before? That's an imaginary number. It's not real, right? 7 times itself is not negative 49. But 7i, 7 imaginary units. So, here's the deal. It's a simple rule. It's a little weird. It's simple. Whenever you have the square root of a negative number, let's do that a little better there. Whenever you have the square root of a negative number, you end up having an I pop out. It becomes imaginary because you can't take the square root of a negative number. You try it in your calculator, give you an error. You can't do it. So, but it's a simple rule. We just pop out the I. Now, I know that might seem like we're making stuff up, but it has an important purpose, and we don't got time to talk about the real life. You type into Google, there's a million real life applications of imaginary numbers. Engineers use them all the time, but we don't got time right now. So those are the two answers. So when you have a negative in a root, it pops out an I. Does that make sense? With that, let's do number 29. We're going to have to stop with 29. It's an important one to do. 81x squared minus 18x plus 2 equals 0. In fact, we're running out of time, so I'll just do it with you. So this is this is going to be quad. I'm just going to jump right into the quad. Right? With an x squared, you can jump right into the quad. So negative b, probably going to use a couple screens here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that'll be, here we go. I'm going to plug everything in. Remember what you do when you plug into any formula, you put parentheses around the number. So I'm going to put parentheses around this 81, parentheses around this negative 18, and parentheses around this plus 2 as I plug them in. So negative 18, right? The negative from the formula and then the negative from the b. Again, two negatives, positive, right, in a minute. Plus or minus the square root of b squared minus 4 times a times c. I'll tell you in advance, this one's going to end up becoming a negative in the root, and so we're going to do the I thing again. I wanted to show you one of the I problems using the quadratic formula. It's going to be the same issue. We'll get a negative number in the root, and that pops out an I. All right, so it sounds bad. Pops out an I, but you know what I mean. All right, two negatives on the 18. That's positive 18 plus or minus. Use your calculator, and please tell me, what's 18 squared? 364 or something like that? 324? Thank you. 324 minus, and then these guys just multiply them in your calculator, and 648, I think. A little more confident about that one. Right? And now I'm going to reach for my calculator too. Subtract those big numbers in the square root. 324 minus 648. Oh, minus 324. Okay. So this becomes plus or minus square root. This is going to become minus 324 in there. Now, do you see how we ended up with a negative number inside the root? So what do you do when you see a negative number inside the root? It pops out an I. So in other words, you grab that negative and you put an I right in the front. So it's almost like the 2-for-1 root thing, but it's the negative pops out an I. So you take that negative and you just send out an I, because that means it's no longer real. It's imaginary. It pops an I right to the front of the root. Like that. And then you just go on and do the rest of the problem like normal. What do I mean? Well, you got to break down the square root of 324, don't you? That's a big one. Use your calculator. I'm going to use mine. I don't know what goes. I just know 2 goes in there, so I'm just going to start there. 2 and 162 And that's 2 times 81. That's 9 times 9. That's 3 times... Actually, I'm going to stop at the 9, 9. As soon as you've got a matching pair, you don't have to keep going down. If you see 2 of anything, ship it out right then. You could go down 3, 3, 3, 3 if you want. It's not wrong. But I'm saying you can save some time. If you ever see 2 of anything, right then ship it out. That's the whole deal, right? 2 for 1. So I'm going to break it down just like that, right there. And I'm going to say, okay, so what we got, bringing this over here, we've got, square root of 324, I should say, is the square root of 2299. Oh, I could have just hit the button on my calculator, that means. That means it's 18. It's clean. I didn't even think about just hitting the button. How do I know? How am I seeing that? Because everything comes out, you see? 2, 2, right? 2 2's in. You just take all the things that are at the bottoms of the trees. 2, 2, and 9, 9, right? 2 2's in. 1, 2 out. 2 9's in. 1, and they multiply when they come out, just like they were multiplying on the inside. 2 times 9 on the outside. 18. Now, what's left inside the root? Nothing. So the root vanishes, which means the square root of 324 was just 18, which means I should have just hit the button on the calculator. That was all just silly. I didn't realize it. I just didn't recognize it. It's just a big ugly number. I didn't go, yeah, that's the root of 8. That's 18. But that would have saved time. You could have just hit the button. It's 18. So let's finish up this problem now. So finishing this up, 18 plus or minus I times 18 all over 162, right? And does 18 go into 162? Does it? Well, what's 162 divided by 18? Oh, it's 9. That's nice. So these guys both go in there 9 times. Remember, it does both. So what does that leave then? Leaves a 1, leaves a 1. So it's 1 plus or minus I all over 9.